Picture a planet so extreme it defies belief. A world where oceans of lava churn under a star that fills the sky, where a year lasts less than a day, and temperatures could melt steel. Meet CoRoT 7b, a super-Earth 489 light-years away, discovered in 2009 as one of the first rocky planets beyond our solar system. It's a place of scorching mystery, a cosmic riddle that's tantalizingly close to Earth in composition, yet alien in every other way. What secrets does CoRoT 7b hold? Could it unlock the story of how planets like ours are born, or hint at fates we can barely imagine? In this journey, we'll unravel what we know about CoRoT 7b, from its fiery birth in the data of a pioneering satellite to the cutting-edge science probing its depths today. It's not just a planet, it's a question mark in the cosmos. Why should you care? Because every discovery here edges us closer to understanding our own origins and the vast possibilities of the universe. Let's dive into the inferno of CoRoT 7b and see what it reveals. The tale of CoRoT 7b starts not on its blistering surface, but in the ambitions of earthbound explorers. In December 2006, the CoRoT satellite, named for convection, rotation, and planetary transits, launched from Kazakhstan, a joint effort led by France's Nice Space Agency. Its mission was bold, to scan distant stars for tiny flickers, signs of planets passing in front of them, a method called the transit technique. CoRoT wasn't just a telescope, it was a cosmic detective. On February 3rd, 2009, the breakthrough came. At a conference in Paris, the CoRoT team announced they'd spotted CoRoT 7b orbiting a star in the constellation Monoceros. Measuring just 1.58 times Earth's diameter, it was the smallest exoplanet with a confirmed size at the time. A rocky world, not a gas giant. The discovery was a game-changer, confirmed by Swiss astronomer Didier Queloz and his team using the HARP spectrograph in Chile. They calculated its mass at roughly 4.8 Earth masses, later refined, proving it was a terrestrial planet with a density near Earth's. This wasn't a fluke, it built on decades of exoplanet hunting. The first confirmed exoplanet, orbiting a pulsar in 1992, shocked the world. Then came hot Jupiters in the 90s, massive gas giants hugging their stars. CoRoT 7b was different, a rocky enigma orbiting every 20 hours, so close to its star that its day side could be a molten hell. Was this what Earth looked like billions of years ago? The find sparked a frenzy. It's a milestone, Queloz said at the time. We're finally seeing planets that might resemble ours. CoRoT 7b's discovery marked a shift. It proved rocky worlds weren't rare, and that our galaxy might teem with them. But its extreme nature raised new questions. How does a planet survive such heat? What does it tell us about planetary evolution? The stage was set for a deeper dive into this fiery frontier. So, what's the deal with CoRoT 7b? Let's unpack it step by step. It orbits CoRoT 7, a K-type star cooler than our Sun, a scant 2.6 million kilometers, 23 times closer than Mercury is to Sol. Its year lasts 20 hours, 29 minutes, and 9.7 seconds, meaning it's tidally locked. One side bakes in eternal daylight at over 2,000 degrees Celsius, while the night side freezes at minus 200 degrees Celsius. Imagine a planet split between fire and ice, with lava oceans rippling under a star that looms 360 times larger than our Sun. Size-wise, it's a super-Earth, 1.58 times Earth's diameter, with a volume nearly 4 times ours. Mass is trickier. Queloz's initial 4.8 Earth masses was challenged by later studies, like Silvestre Ferrazmelo's 8 Earth masses, before settling at 6.06, give or take. That gives it a density of 5.6 to 10.4 grams per cubic centimeter, close to Earth's 5.5 or Mercury's iron-heavy 5.4. It's not a gas puffball, says astronomer Ignace Snell. This is a solid, rocky world, possibly a stripped-down survivor. What's it made of? That's the million-dollar question. High density suggests an iron-rich core, maybe 30 to 40% of its mass. topped by a silicate mantle. But its proximity to CoRoT 7, a mere 1.6% of Earth's distance from the Sun, means it's been hammered by stellar radiation. It might have lost its outer layers, theorizes planetary scientist Laura Schaefer. Think of it as a planet boiled down to its bones. Some models propose it was once bigger, its atmosphere and crust vaporized over billions of years. The proof keeps stacking up. In 2011, NASA's Spitzer Space Telescope nailed its transits across multiple wavelengths, confirming its rocky status. Its surface? Likely a dayside lava ocean, molten rock flowing like rivers, with a night side of frozen stone, or a twilight zone where temperatures balance out. If you stood there, Schaefer muses, you'd see a glowing Hell's Cape, the star a relentless furnace overhead. Crazy, right? CoRoT 7b has company. CoRoT 7c, orbiting every 3.7 days with 8 Earth masses and a possible CoRoT 7d, a Neptune-sized world at 9 days, hint at a packed system. How do they form so close? Did they migrate inward, or were they forged in this fiery chaos? One theory, CoRoT 7b is a gas giant's corpse, its outer layers cooked off, leaving a dense core. Data from the European Space Agency suggests it's 5 billion years old, older than Earth, making it a relic of cosmic history. Here's where it gets wild. CoRoT 7b mirrors Earth's infancy, a molten ball bombarded by radiation. Could it reveal how terrestrial planets evolve? It's a natural lab, says Sarah Seeger, exoplanet pioneer. Every detail we uncover reshapes our understanding. Its extreme conditions are the climax of this tale. A planet pushing the boundaries of what's possible, daring us to look closer. It's 2025, and CoRoT 7b still captivates us. With tools like the James Webb Space Telescope and TESS, NASA's Transiting Exoplanet Survey satellite, we're peeling back more layers. Yet, mysteries linger. Its mass, pegged at 6.06 Earth masses with a wide error margin, keeps scientists guessing. Did it always weigh this much, or has it shed half its bulk to stellar winds? Recent studies lean toward erosion, estimating a loss of up to 100 Earth masses over its lifetime. The star's a troublemaker too. CoRoT 7's flares and spots mess with radial velocity readings, scrambling mass data. It's like chasing a ghost, says Seeger. Still, progress creeps forward. Spectroscopy hints at a thin atmosphere, maybe sodium or iron vapor, condensing into metallic rain on the night side. Picture that, a planet where molten metal falls from the sky. Today, CoRoT 7b is a cornerstone of exoplanet science. With over 5,000 known exoplanets, it's a gold standard for super-Earths in extreme orbits. But its distance, 489 light-years, means we're stuck with indirect clues. The challenge? Refining our tools to pierce the stellar noise and see what's really there. The trend's upward. Each year, we know a little more about this fiery enigma. What's next for CoRoT 7b? The future's a blank slate, but the possibilities are electrifying. By 2030, the extremely large telescope could pin down its mass and sniff out atmospheric traces. Even a faint signal, says David Ehrenreich, could redefine super-Earth science. Imagine confirming iron rain or a vaporized crust, textbook stuff rewritten overnight. Over eons, its star will dictate its endgame. CoRoT 7 will balloon into a red giant, possibly swallowing its planets. Before then, CoRoT 7b might erode to a husk, or hold steady as a scorched survivor. It's at a tipping point, Schaefer predicts. Either it stabilizes, or it fades into dust. Some even wonder if the system hides distant, habitable worlds waiting to be found. The stakes are cosmic. CoRoT 7b could guide us to Earth 2.0 by showing what to avoid or what to seek. As our tech sharpens, its secrets might illuminate the galaxy's past and future. Are we on the cusp of a breakthrough? Only time and the stars will tell. CoRoT 7b is a paradox, a rocky world like Earth, yet a furnace of extremes. We've traced its path from a 2009 discovery to a symbol of planetary resilience, a super-Earth with lava seas and a story etched in starlight. It's taught us that rocky planets thrive even in chaos, that our own origins might echo in its molten core. But so much remains hidden: its true mass, its past, its fate. This isn't just science, it's wonder. CoRoT, 7b dares us to ask, how do we get here? What else is out there? As we peer 489 light years away, it's a reminder of our curiosity, our drive to explore. So, next time you look up, think of this fiery sentinel and ponder the mysteries still waiting in the dark.